This grant ensures we stay ahead of schedule. The public investment is crucial for the next phase.
Amount of wave energy density, 2 to 3 kilowatts per meter of wave crest typical, concentrated power, high energy flux.
The simulation results align perfectly with the physical data here.
Yes, the heave response is exactly as predicted by the model.
Scaling presents significant challenges. The simulation looked perfect, yet the full-scale structure is showing critical failure points the model didn't predict.
All systems operating at peak efficiency.
Acknowledged. Predictive maintenance is green across the board.
Operational constraints mean we rely entirely on a clear weather window, a calm period to install.
The tidal currents here are the strongest in Europe.
Which is precisely why the Scottish Government is committed to accelerating this deployment.
A true world leader.
The market mechanism is clearly defined right here.
Excellent. This secures the revenue for the next 20 years. Let's sign the agreement.
The stress tests on the propulsion system show critical failure points. How do we underwrite this?
The financial exposure is significant. We need better mitigation strategies.
Check the alignment on Sector 4, then apply 300 Newton meters.
Confirmed. All tolerances met. Logging the data now.
This throughput graph shows a critical bottleneck right here at the wiring harness stage.
I agree. We need to reevaluate the integration sequence immediately to scale production.
We need to monitor alignment closely during the lift.
The tolerances are tight, but the module fits the spec.
Keep me updated on the pressure readings.
The electromagnetic fields radiating from these cables are clearly affecting local marine life.
It's the exclusion zone. We have nowhere else to go.
And now the nets are destroyed. How are we supposed to live?
Close-up of fatigue loading, cyclic stresses from millions of waves, material challenge, durability requirement.
Powerful swells carrying enormous energy, an untapped renewable resource.
Wind transfers energy to the water surface, creating small ripples. As the wind intensifies,
We characterize ocean waves by their height, the vertical distance from trough to crest, and their wavelength.
This articulated motion drives the hydraulic pumps, capturing the wave's energy and spinning the central turbine for efficient power conversion. In this simple mechanical approach, waves overtop the barrier, filling the basin. The stored water then drives the low-head turbine.
Biofouling is the accumulation of microorganisms, algae, and animals on submerged
shot of anti-fouling coatings, preventing organism attachment, surface treatment, maintenance.
Wave-to-wire efficiency, capturing the raw power of the ocean and converting it directly into usable energy.
Close-up of PTO efficiency, conversion losses in hydraulics or generator, conversion performance, and secondary loss.
The sound pollution from these devices creates powerful acoustic emissions. As the sonic waves intensify,
as sea turtles navigate coastal waters, they face significant collision risks from underwater devices like these turbines.
I wasn't sure how I'd feel about the view, but in this light, they look quite majestic.
As you could see, the levelized cost for wave power sits between 2020.
The capital costs have already reached 77.50 million, and we project needing another 175 million.
The lack of transmission infrastructure here represents a significant development barrier, despite the abundant wave energy.
The wave predictability gives us a clear operational advantage here.
Confirmed, Captain. Maintaining course.
The articulation on the prosthetic is remarkable.
Yes, but the water system's scalability is higher. We need to weigh the impact.
Point absorber dominance. Buoy designs most commercially advanced. Emerging winner. Technology leadership.
Set team. One specific niche application. Go for niche application.